Hello and welcome to the Dairy Digressions, the new podcast from the American Dairy Science Association. I'm Dr. Matt Lucy, Professor of Animal Science at the University of Missouri and Editor-in-Chief of JDS Communications. On this podcast, I'll speak with some of the top minds in dairy science and explore their research as well as important trends in their respective fields. If you enjoy Dairy Digressions or have feedback for us, please let us know at adsa@adsa.org. Please make sure to like, subscribe, and rate us on whatever platform you're listening on. Today, we have with us Dr. Jan Dijkstra from Wageningen University in the Netherlands, and we are going to talk about farming and the environment in the Netherlands. Jan is an associate professor in the Department of Animal Science. He's a prolific researcher in dairy nutrition at Wageningen and a member of the JDS Club 100, meaning that he has authored or co-authored over 100 papers in the Journal of Dairy Science. The Netherlands is the world's second largest food exporter, second only to the United States, and gets this done with a total land area that ranks 22nd in the European Union. The Netherlands is approximately the size of the state of Maryland in the United States or Vancouver Island in Canada. Producing so much food within a small land area has put the environmental impact of farming front and center for this tiny country. We'll unpack all that and explore what science has to offer in today's podcast. Welcome, Jan.
Hi, Matt. Great to be here.
It's fantastic to have you here. So I wanted to start with the numbers, okay? It's true you live in a small country. Fair?
Yeah, indeed. It's a small country and many people and also quite a bit of livestock over here. Cows, pigs, poultry, yeah.
So I was reading, so first of all, 17.5 million people, that doesn't seem like a lot, but that's in terms of density, that's second in the European Union in terms of the density of people.
Yeah, so it's pretty dense.
And at the same time, okay, 1.6 million dairy cows, right? Now for you US people, and that equates to somewhere between the number of cows in the state of California and the number of cows in Wisconsin. So you don't have as many as California, but you got more cows than Wisconsin. Just toss in 12 million pigs just for the heck of it, okay? And so in America, we have 70 million pigs. You just toss in 12 million. And you're doing this, again, as I mentioned in introduction, in a land area at approximately the size of Maryland. You're a little bit larger than Maryland, okay, which would be considered a very small state in the United States, okay? And so I just didn't get this. I was telling, we were talking about the other day, when you grow up in America, I guess we say the Netherlands or Holland, windmills and tulips and, and I don't know what else we learn about that, but that's what we get. That's the information we get, And so, but we're going to unpack that. But in Dairy Digressions, what we do is we kind of start learning a little bit about you, and then we'll kind of work our way through the different things. So I'm assuming you're Dutch. You're born in the Netherlands?
I was born in the Netherlands. Yeah, I was born in a town called Assen, which is the capital of a province called Drenthe.
Yeah.
It's somewhere in the north of the country.
So is that a big dairy region in there?
Not really. My surname is Dijkstra, and that makes it clear to at least Dutch people that I'm from the province of Friesland.
Ah, yeah.
Friesland is the dairy province of the Netherlands, basically. So, my parents were actually the first of their large families to move out of Friesland. So my family on my mother's side, most of them still live in Friesland, and my parents were the first to move out to another province. As my dad always jokes, he said, "I wanted to develop the rest of the Netherlands outside Friesland."
Yeah. Is Friesland the region of the Netherlands that's below sea level? I'm just trying to get my mind around this.
No, not really. Oh, there are obviously parts in Friesland that are below sea level, but Friesland is from origin also parts above sea level. It's not major polders that are below sea level, like in north of South Holland, for example.
Now we're going to talk about climate today, and we're going to talk about greenhouse gases and stuff. But this is an aside, and it's a digression at least. But are you guys talking a lot about sea level rise as well in the Netherlands, or not?
Well, a lot, but yeah, sure. We're in general, there's worries about climate change and what it means for the Netherlands. Obviously, sea level rises are a major element that we are talking about, and how to protect our own country against it. Obviously, we have a long history of dealing with water and high levels of water, etc. So there's also a general tendency in the country that says, okay, we'll solve that problem as well. We've always dealt with water, and we're going to solve a rise in sea levels as well.
Yeah. So what do you have I don't know, how many square kilometers does the country have that's actually below sea level? Is it
Ooh.
half the country, or a third of the country? Or?
To be honest, I don't know, Matt. Probably a third is my best guess, but yeah, I should have to look it up.
Yeah. So you do think a lot about water and sea level and all that stuff. Yeah.
It's talking a lot about water. It's also the other way around, because of climate change. We've experienced a couple of very dry summers, and obviously that's the other way around. Groundwater levels are decreasing. How about our drinking water, etc.? So it's also trying to keep the water where it should be for a longer period of time, that it doesn't rush off so quickly to the sea, that we maintain enough water for the crops and also for drinking water, etc.
Yeah. So tell me how you got interested in dairy cattle.
Yeah, I'm one of the probably few dairy researchers that wasn't born or raised on a dairy farm.
Oh my gosh. Okay. I had that totally wrong. I was like, this guy is a Dutch dairyman. Not true.
Not true. No. My family in Friesland, there were lots of people there with farms, and I was interested in that, obviously. But all my life, young life, I've always wanted to become a veterinary surgeon. And in the Netherlands, the vet school is in a town called Utrecht, which is like 50 kilometers west of Wageningen.
Yeah.
So our vet school in the Netherlands is not linked to the animal sciences groups, right?
Okay.
And at that time, there were plenty of people who wanted to study veterinary sciences, and it was simply a lottery at that time. So there were like more than 1,000 people interested in joining it, but only 150 or so could actually be allocated to the study. And it's a lottery, and I was looking afterwards, lucky not to have entered the Utrecht system, but that's only afterwards. So I was unlucky at the time to not have been selected. And then I started my study of animal sciences in Wageningen. But I really liked it very much in Wageningen. So after a year, I did participate again in this lottery.
Yes.
And it was actually selected at the time.
Oh, wow.
And all my friends, I have many friends, studying here, all in the same position, not in Utrecht, always wanted to be in Utrecht. They all thought I was mad to say, no, I don't want to go to Utrecht. I like Wageningen too much. So the study was really, I really loved the study in Wageningen.
So I have a question. Again, it's sort of a digression to a certain extent. This lottery, in America, we train mainly women to be veterinarians at this point. Okay, so in animal science, we're probably 90% women in animal science because they're pre-vets. The vet school is mostly women. I taught a class in large animal, not a class, I gave a lecture in large animal. There was rotation. There was 16 women and one gentleman in that class. Okay, so when you do the lottery, how do they balance gender? Do they still do the lottery, or how does that all work?
They still do the lottery, and they try to get people in there that are interested in indeed large animals like the cows, the pigs, etc. Because same as you just told me, a lot of women interested in the study, but they generally tend to be more interested in like the companion animals and horses.
Okay.
So
Okay. Yeah.
there's becoming a shortage of veterinarians for like cattle and
Okay.
pigs, and that's
Okay.
what they try to stimulate.
Yeah, we're in the same. I'm sure you're aware. Bovine practitioners is. Just saw a tweet on that. They're just very concerned about the flow of large animal
Yeah,
veterinarians into the
yeah,
profession. So it sounds like Europe is somewhat similar with that respect to that.
yeah. Yeah, same here. It's seen as a very tough job, obviously physically demanding, lots of working hours. It's generally not seen as a nice job to be in from that perspective.
Yeah, and yeah, yeah. It's interesting. It's interesting. I tell people that I really, even among graduate students here in America, we get mostly women in animal science, very few men. And so I tell people I work mainly with women, that's who I work with. I
Yeah.
teach women, I work with women. And it's an interesting, you never would have predicted that when we started down this road.
No, no, same here. I just came back from my class this afternoon. It's around, I think it's 70% women, 30% men.
Yeah, it's those kind of numbers.
Yeah,
Interesting. So
yeah,
you are a scientist, you're an associate professor. The European system is a bit of a mystery to me. You have, I don't know, lecturers, maybe you don't in the Netherlands. I mean, I don't even, but tell me, okay, so you got your PhD. I see you postdoced in the UK at some
yeah,
point, and
yeah,
then
I
you
did.
come back
Yeah.
to and I hesitate to even try to say it too many times. You know how I learned how to say Wageningen is, but I still say it wrong, is I had to listen to it on a YouTube video, and I still can't say it right. But I'm
The proper
close.
thing.
I'm not too bad.
No, no, no. It's quite understandable, Matt. It's excellent. Yeah.
I was gonna say to all you podcast listeners that don't know what university we're talking about, it's the one that starts with W and all the research comes out of. Okay, it's that one, but so you came back, and do they have the same system there? You start out as an associate professor, or excuse me, an assistant professor,
Yeah.
associate, tenure, and that sort of stuff.
Yeah. Yeah. It's a bit different that you don't, if you don't want to, there's no real need to like go up in the ranks, if you like. And
Yeah.
to become a professor is really more difficult. It used to be that only the leader of a big group, like I'm from the animal nutrition group, and the leader of that group would be the only one to become a professor. But in the past couple of years, that has changed. Now you can also become what they call a personal professorship. And that can be done. It's indeed a lot of work to do, but it is possible now. But otherwise, it will be assistant professor, associate professor, and usually that will be both doing research as well as education.
So what do they have splits? We talk about splits like 60-40. Is it this? What is your split for
Yeah, my
research
split,
teaching?
I don't have it real official, but the split is roughly 50-50.
Ah, yeah. So you're expected to teach classes then.
Yeah, teach classes. So like I said, I've just returned from a modeling class with 40 students. So quite nice, great group.
Mathematical modeling. Oh my
Yeah,
gosh.
yeah, mathematical modeling. So that's obviously a challenge here to get students into the mathematics, because
Yeah.
yeah, the way they teach these days mathematics at high school is a bit different from when I went to high school.
Yeah.
So it can be a bit tough now and then to get them into that. But then you have the software that does most of the mathematics for you, so that they don't read a real understanding of the mathematics, but we work in differential equations to describe changes in like digestion or metabolism of nutrients, etc.
Oh,
And they
fantastic.
need to have a bit of background on that.
Yeah.
And in my classes, we deal with different topics. So we can deal with models about nutrient metabolism in dairy cattle. But this afternoon, for example, we had a class on calcium and phosphorus dynamics in layers. So
Wow.
calcium being utilized for the eggshell mainly, and that drives to losses of phosphorus from bone mobility. But I always try to tell them, and also what does it mean for other species, like calcium phosphorus dynamics, obviously very important also for dairy cattle in urban lactation, right, with milk fever, etc.
Yeah. So this does you also teach dairy nutrition then, I imagine.
Yeah, also, but yeah, I'm doing also other species nutrition. So, sorry, it was just.
So
We
you
have to cut
teach
this one
dairy
out.
nutrition, and then would you rank when you talk about at the University of Missouri we have the ag school, agricultural college, but we have lots of colleges, and I'm imagining at Wageningen that there's also different colleges, for example. Does the ag school at Wageningen, is that a big one? Is that the reason that this university exists, or
Yeah.
are there lots of different? I mean, do you have engineering, arts and science? I don't know, whatever.
It's linked to life sciences, what they call these days, and it can be anything: human nutrition, for example, environmental aspects,
Yeah.
but also social studies that are. But somehow it must be related to life sciences.
Oh, to be
Traditionally,
there.
yeah, yeah. So
Oh,
traditionally, it was really the traditional agriculture, so to say.
yeah.
But on top of that, we have those environmental studies, soil studies. You mentioned it, but somehow related to how to use,
Oh,
nature, agriculture, farming
oh,
together.
so that's a nice focus then for your university. So most of
Yeah,
the people are in that realm, sounds like.
yeah, yeah. So it's really the only university that delivers those type of topics. Hey, if you go to law or whatever, you have various different universities in the Netherlands, but to go to life sciences, basically, Wageningen is the place to be.
I don't think we have, I'm a Cornell guy, and Cornell had all the, it's known as an ag school in New York State, but there's a lot more than ag at Cornell, and most land grants have lots of different things we do,
Yeah.
that's different. That's a different sort of model, I think, which is interesting.
Yeah, but traditionally it was completely ag, and obviously now it's like nature studies, environmental studies as well, but we call it then somehow
Yeah.
linked to life studies, basically.
So do you run a lab? Obviously, you've got this teaching component, but do you also have a lab component? Do you do the same stuff we do, grad students, postdocs, all that stuff?
Yeah, so we tend not to term it our own lab or something. That's a bit different from your North American situation.
Ah,
We feel, or we're working in a group like the animal nutrition group with various associate and assistant professors over there. We share the facilities completely. We share lots of the facilities with other groups, adaptation group or other groups within the animal sciences. And we specialize, like I'm a ruminant nutrition person, but we also have a pig nutrition or a poultry nutrition or companion animals specialist over there. And then in our system, we hardly have postdocs. So we work a lot with PhD students. That's our major goal, basically, the PhD students, as well as the MSc students. But then our MSc students, it's different from your MSc students. That our MSc students, for example, do only a major for only 6 months period of time, their major research.
wow,
All
okay.
right, and the rest is mainly courses or an internship of a couple of months. So the MSc is basically 2 years on top of a BSc period of 3 years. Our
Yes.
typical study is 5 years.
Okay. So are you expected as a associate professor, like in the United States, it's all about getting grant money, getting funding to fund the research. This is all part of the plan as well, right? Proposals, attract funding. And you might write a proposal to the European Union, for example, or maybe the government of the Netherlands, or is it just European Union?
No. It's European Union. Those are also the very big projects with lots of groups in there. So quite big. We can get money from the government. On fundamental research, you go to the Dutch research organization that hands out that money. Again, chances to get it are pretty low. Success rate is low. And we also have a lot of our research is linked with, say, feed industry, and often in a way that our government sponsors a part of the financial costs and the feed industry sponsors the other part. Like often our research is then 50% sponsored by the government, and 50% by feed industry, which is attractive to both, right? Because you get often kind of research that can be utilized in practice. And for
Right.
feed industry, it's attractive to go to those PhD positions because
Yeah.
part of it will be sponsored by the government, and they get all
Right.
this new knowledge for not too much investment, financial investment for themselves.
Right. So that I think this sort of transitions into what's happening in the local dairy space in the Netherlands. And I must apologize. Okay. I really wasn't paying close attention to the situation in the Netherlands. What I knew about the Netherlands, I talked about earlier, but we also know that Dutch farmers are very famous in America. Okay, they're famous for being outstanding farmers. It's synonymous with the ability to start with very few cows and very few resources and build huge, successful, economically successful dairies and well-run dairies. So that is the image of the Dutch dairyman, okay, in America. Very positive. And I just hadn't put it all together until I saw an article, it might have been in the New York Times or somewhere else, where they said, you know, the government is looking to reduce cow numbers. I mean, actively reduce the number of dairy cows in the Netherlands. And I was like,
Yep.
wow, that's interesting. I mean, I guess that's one way to mitigate the environmental impact, is
Yep.
get rid of the cows or get rid of whatever. Is that front and center right now in your industry, this notion that we're going to get rid of some of these farm animals? Or
yeah, that's very much a talking issue these days in the Netherlands, in the sector, all the livestock sector in the Netherlands. And that the reason for that at the moment is simply the what we call the nitrogen crisis. There's a surplus of nitrogen from various sources, but including livestock, surplus of nitrogen on nature areas, and that has negative effects in terms of biodiversity, in terms of different plants that you see there, birds that have weakened bones, all kinds of things. And they want to reduce the nitrogen deposition, especially on nature areas. So if you look at...
Okay, so the first thing I would say is I didn't even know you guys had nature areas. It just looks like it's all farms. Okay, so somewhere there's some wildlife.
Oh yeah, there is. We even have that's a hot issue as well. We even have 4 years ago or so the wolf coming back in the Netherlands.
No kidding, the wolf.
Which is a major issue because we haven't had a wolf in, I don't know, 100 years. I'm not sure when the last wolf was shot.
Oh, that's fantastic, right?
And now, obviously, we're not used to that as a predator, so we have to somehow protect, like the sheep. But those wolves kill a lot of sheep in the Netherlands. So farmers are really worried about its introduction of the wolf. But it's protected by European law, so you can't shoot them basically, unless they're really causing a major problem, and you can't do anything else. Then you can shoot them, but so far none have been shot in the Netherlands, and farmers are really worried about it. They also attack cattle, for example.
Where did they come? They come out of Germany, or where did they come out of?
Yeah, they come from Germany, and then they spread also in the south. It's Belgium, also in Belgium now, for example. So yeah, they find a nice living area over here in nature, but obviously attacking also prey that is more easy for them to get.
Yeah, I don't own cattle, so it's not fair for me to talk too much about it. But for me personally, I love wolves. I love that stuff, you know. And as you know, there's been it's not fair for me to. I don't own cattle, okay, so I'm not impacted economically by the wolf, but there's been many introductions, and you know, if you don't shoot them, they tend to do quite well, and hopefully they attack wild animals, not your domestic. So
and they can really be a benefit for diversity in wild animals, right? If they attack the wild animals, so that's a major benefit. but obviously they may also attack sheep in particular.
Yes.
And then you see this division between like city people and people in the rural areas.
Right.
The city people say, hey, you have to protect your sheep with dogs or keep them inside during night, etc. You know. And for the farmers, obviously that sheep farming is already, it doesn't give you a lot of money. There's simply no way to invest in that or to put in all this effort each day to get your sheep inside or to train a dog to protect against predators, etc. So it's a major division again between people in the cities and people in rural areas.
I had no idea. I had no idea that this was going on in the Netherlands. That is absolutely fascinating. You mentioned the nitrogen. Now, I was thinking when you said there's a nitrogen crisis, I was thinking nitrous oxide into the atmosphere. But when you say nitrogen, are you talking atmospheric nitrogen or are you talking groundwater nitrogen or all of the above?
Groundwater nitrogen may also be a problem, and nitrates in water. But the major issue these days is simply nitrogen on nature areas because by law, European law, and we've committed to that, you're not allowed to deteriorate nature areas. And that means basically if you have an activity that emits nitrogen, therefore deposits nitrogen on the nature area, that's basically not allowed because the nature area will deteriorate from it if it's vulnerable to too much nitrogen. And therefore, lots of projects in the Netherlands are at the moment at a standstill, like major housing, new housing. That process of building a new house and all this traffic, etc., emits nitrogen. So that's not allowed.
It does?
Yeah, it does. It's only a little, but even a little extra is you have to ask a permit for it. So the amount, it's ridiculously low. It's only 0.07 grams of nitrogen per hectare per year, which is already
0.07.
0.07 that already has to make you to ask for a permit. All right. And then if there's at the moment, a lot of it is at a standstill because the nitrogen levels are too high. All the judges, when they go to court, hey, the nature groups or whatever is fighting a new farm or a new road or new housing as activity, they go to court and then court says, yeah, we need to protect nature. You can't do something that deteriorates nature. So
whoa, yeah, that's fascinating. You know, as you can imagine, in America, we are land rich. In America, land rich. I mean, again, we're talking about a country the size of this, slightly larger than Maryland. Boy, I tell you one thing about America, if you just leave that, I don't know, 50,000 square kilometers alone, nature will do a pretty good job of taking over, you know, so I'm sure we don't manage our natural areas as aggressively as your country is managing those natural areas, you know, so I thought today we would, so the nitrogen situation is all new to me, but everything is new to me. I'm a reproductive physiologist, so everything is new. But I thought we would I thought we would talk about greenhouse gases and because I know you've done a lot of research on that. This is front and center. You don't think about it, but it's actually front and center in the United States as well. And we hope to turn sort of carbon neutrality or greenhouse gas neutrality into a win for the dairy industry, but it's going to take some work. You know, I was listening this morning, I was listening to Progressive Dairy podcast, which is Progressive Dairy has a podcast and I just really enjoy it. And they had Mike Haddon from the Dairy Innovation Center and a Susan Vold from Minnesota, dairy farmer. And it was all about this question of, okay, so how are we going to achieve, they called it greenhouse gas neutrality instead of carbon neutrality by 2050. And I know that's near and dear to your heart, you know, and I want to give a shout out to Progressive Dairy Podcast and the host, Jen Coyne this morning, and also Kimmy Devaney and Peggy Coffeen. Those guys do a great job of just, it's fascinating. You know, we think of Progressive Dairy as a real sort of management kind of magazine, but these guys are, you know, American dairy farmers and American dairy industry is talking a lot about the same things you guys talk about. But of course, you guys are, I would argue it's extremely pressing issue for the Netherlands, whereas in America, it's a coming pressing issue. I don't know if that's fair or not, okay, but that's the way I think.
Yeah.
And so I want to talk about, so one of the things we try to do in this podcast is we talk about different articles that I see in the Journal of Dairy Science, and I saw you had this article on, I call it 3-NOP, you call it 3-OP, 3-nitrooxypropanol, and its effect on methane production and yield in cattle. And what you had there was a meta-analysis. And I think when I came through graduate school, we learned about monensin, okay? And monensin also affects methane production. But monensin is a different molecule. It works in a different manner. Can you just tell us a little bit about this 3-NOP, maybe about its mechanism of action?
Yeah.
And then kind of summarize, you know, if you feed this stuff, what's the take-home message of feeding this 3-NOP on methane?
Yeah. So 3-NOP is an ester of nitrate and propane diol, and it has a shape, a molecular shape that is similar to that of methyl coenzyme M, and that's a cofactor that is involved in methyl coenzyme M reductase, and that's the final and major step in methanogenesis in the rumen. And that enzyme is a nickel enzyme, and it needs to have the nickel in the 1 oxidation state. Now, if this 3-NOP binds to the reductase, it places electrons in a position that changes that nickel ion in such a state that the enzyme becomes inactive, right? So it's basically, it's neatly done by the company from molecular docking studies, that they derived this molecule and found out that it's doing this powerful job in reducing methane. But it's a temporary effect. So the methanogens, they have an easy repair system with a hydrogen-dependent chaperone process, in which they can regenerate the enzyme basically again. So after this 3-NOP has been metabolized in the rumen, and it goes pretty fast, you're back to normal, which is, for example, a problem if you have like animals grazing a lot and only, for example, come in a couple of hours a day to eat the feed that contains 3-NOP. Well, all the time during grazing, or most of the time during grazing, the molecule is already gone and the system has repaired itself, so it's not active. Right. So the study that we did was only in confinement systems, basically, where the 3-NOP is added, in the diet itself. So every chew, every bite will have it in it. Yeah. But it's sorry. Yeah.
So to sort of quick aside here, we think of confinement dairies oftentimes in America, and I just kind of popped in my head that you mentioned grazing cows, but also coming inside to eat. And as I remember, there are laws in the Netherlands that say a cow must graze for a certain amount of time, or is that not correct?
No, that's what some people perhaps would like to see. We have like in a parliament, we have a party for animals, which is very outspoken in that direction, for example. Okay. But no, it's not law. You can have cows inside all year long, but like 80% of the farmers practice some form of grazing, and the usual type of grazing is, say, only in summertime, obviously, but 6 to 8 hours a day grazing outside, and the rest of the day inside, eating whatever there is, grass silage, maize silage, the concentrates, obviously. And that's then for the 3-NOP business, that's the time that the cows will also eat and consume 3-NOP. But
So
like,
that's, yeah, so the fact that so while they're outside, that their methane production may go up because they haven't consumed the 3-NOP. And I guess
yeah,
you also have to make sure that cows eat regular meals, which I think they typically do, but you need to understand that interval between meals and
yeah.
dosing and that sort of thing.
Yeah. So that's indeed very important. Obviously, when they just eat the meal, go outside. For the first 1-2 hours, the molecule is still pretty active, but you really see after 3 hours, the effect probably is already gone.
Yeah,
Right.
yeah,
So during that last part of the grazing, for
yeah,
sure, the methane is being emitted. Uh, you know, no 3-NOP. So
right.
what we need in that situation probably is to have a slow release way of having that 3-NOP being released in
Ah,
the rumen.
so they make those little slow release sticks for something to treat ketosis. I can't remember the
Yeah,
molecule that is. I can't remember, just old age, but they do make those slow release boluses for the
yeah.
rumen. Is that the vision then for 3-NOP?
Yeah, that might be something that they're looking at indeed. Either slow release that it releases for weeks on end, so that you can have animals also, those animals that don't come in to be milked, for example, but are for several weeks outside. Or you have this slow release type that will release it over a period of say 12 hours or something. And as long as it's when they're back inside at milking and
Yeah,
eat a new dose of the feed with a slow release in it, you're also in business basically.
yeah. That I was looking at this article and reading it, and as I recall, you're getting about a 30% reduction in methane production
Yeah.
with 3-NOP.
Yeah, that depends. What we found in our meta-analysis, the first thing it depends on obviously is the dose. The more you give, the greater reduction. Makes sense.
Right. Yes.
Um, but what we also found, and that's probably really relevant also for the Netherlands, is it depends also in particular on the level of fiber in the diet. The more fiber in the diet you have, the lower the efficacy of this 3-NOP. And that is
Okay.
also for us, like the trigger to do this meta-analysis. We've done a couple of years ago an experiment in which we measured methane emissions on 3 different diets that differed in the ratio of grass silage to maize silage. So basically the ratio of fiber to starch, if you like. And we found that 3-NOP is much more effective on the maize silage rich diet, up to over 40% methane reduction. And well, that triggered us also, okay, apparently the basal diet has an impact on how efficient 3-NOP is. Let's look by a meta-analysis to get all the data that's available from all the experiments that have been done and reported in literature, and
Right.
see if we can analyze what are the factors that explain what we call heterogeneity in the response to 3-NOP. And
Right.
yes, fiber was one of them, and in such situations also fat. So more fat in the diet means that 3-NOP is less effective.
Okay. So so no, we say in America, no free lunch. Okay.
Yeah,
So no free lunch. Okay. So let's take let's take a 3-NOP, and I'm feeding my cows 3-NOP. No free lunch. So tell me about effects on milk production, milk composition, other aspects that are going to put a drag on it.
yeah. Basically, that's very limited, Matt. Only if you give really high doses, but that's higher than the company recommends or is allowed by our European Food Safety Organization.
Yeah.
There are no real impacts on milk production, feed intake, or milk composition.
Oh, yeah.
So that's also from the other side. I mean, when the company started this research, they were hoping, okay, we have less methane. That
Yeah.
saves energy, and methane is energy.
Yeah.
So
Yeah.
more energy will be retained in the animal. So hopefully the animal may produce more milk, that the
Right.
product may pay for itself, if you like.
Yeah.
But that also didn't turn out to be the case. So basically no change in milk production composition unless you go to really high levels of 3-NOP. But
Yes.
that's not the target that you aim for. So it's just, obviously the company needs to make a living. So it costs money.
Yeah.
And the way to pay for it, I mean, you can't let the farmer pay for it. So our dairies are interested in producing milk with a lower carbon footprint.
Right.
And they will give a small financial incentive to do that. So one
Right.
way to do that is, as a farmer, to use 3NOP and therefore have a little extra per liter of milk that you deliver
Right.
to the dairy. And
So
that's the way
yeah.
to that it can pay for it.
So it's going to have to go through some regulatory approval, I assume, and human
Yeah,
or this food safety
yeah.
type stuff. Does it it's not just cows making methane, it's manure piles, right, that make methane. So
Yeah.
is it the same methanogen, the same bacteria that makes methane from manure piles, or
The same principle, the same methanogen types. There are different species in the manure, but in the end, it's an anaerobic process that
yeah,
produces the methane. And we do think that should you add the stuff to a manure pile, it
yeah,
would at least temporarily also decrease the methane over there. Uh,
it's interesting, isn't it,
Yeah, it's
that you could,
interesting. And also have been studies done, okay, looking at does the 3NOP then affect the manure quality, so to say,
right,
like methane emissions or the fertilizing value in the soil.
yes,
And from the studies, only very limited number of studies, but those studies don't show any impact of using 3NOP on like amount of nitrogen in manure or
yeah,
the degradability of manure or impact on the soil processes like nitrogen losses or whatever.
right.
So no impact apparently on the manure, which makes sense if you know that 3NOP is pretty rapidly metabolized in the rumen.
Right. It would make sense then that,
Yeah, it makes
yeah.
sense that you don't see in effect.
Yeah. So in the United States, you know, I think there's a lot of interest in renewable natural gas, capturing manure,
Yeah.
capturing methane from dairy manure. And I guess I wanted to sort of back up for some of our listeners and just explain if that, when we think about controlling methane, theoretically, the whole argument behind monensin, which is a different type of sort of mechanism to control methane, was to increase feed efficiency or increase efficiency, because methane represents energy loss to the animal. And I was always like, why does methane represent energy loss? And you just got to remember, if I can capture methane, I can burn it, and it makes heat, right? And that's the whole concept. And the same thing with dairy manure. If we can capture methane, and we can burn it and for heat or whatever, and in America, of course, the dairies are extremely large. I don't know how large they get in the Netherlands. I should ask you that. What would be a typical dairy? You step foot on typical, not average, typical dairy. How many cows?
Typical is 110, 120 dairy cows on the farm.
What?
So that's
110? Typical?
110, 110, 120.
110 to 120.
Yeah, and that's also we've also looked at obviously methane from manure digesters, but the scale is too small basically, and
Yeah.
then you need to have with a lot of group of farmers, you have to get those manure digesters, right? But
Right.
it's not so practical to do basically.
Yeah. So, and Jan knows this, but for our listeners, the average herd size in America is 300, but that's a skewed average. The typical dairy is well over 1,000 cows, probably 2 to 3, 6, 10. That's right. And when you get into that scale, these renewable natural gas projects are feasible. I don't know if they're profitable. They're feasible. But it's interesting when I listen to a lot of podcasts on this, and I think the important point they make is, if you're going to put in a manure digester, you have to have someone to manage the manure digester. You can't just stick it in there, and it's a science, right?
It's technically very demanding, and a
It's
lot can go wrong. So
Yeah, and when it goes wrong, you got a lot of what to deal with, right? So it's interesting. So
yeah.
the NLP story I thought was really exciting, and I really enjoyed reading that, and I know we're going to talk about another paper that you co-authored, and that has to do with meeting the climate goals. I guess maybe, I don't know if they're climate goals. I guess they are climate goals for 2030 and 2050. And before we talk about that paper, I'll give you a little break here, and I'll just interject a paper that I saw that I found really sort of interesting. But I think it speaks to what we're trying to accomplish here in terms of cattle and the future of animal agriculture in general on planet Earth. And this paper I saw is a paper published in the Proceedings of the National Academy of Science, which is the same place you published your paper.
Yeah.
And the title of the paper is The Global Biomass of Wild Animals. And it's authored by a group led by Laura Greenspoon. And it was published in 2023. And I saw, the reason I picked up on it is they highlighted in Science magazine. And so it's this whole premise. So if you talk about biomass, which is, I don't know, biomass of mammals, they're not talking about biomass of plants and insects. They're just focusing on mammals. And I was like, well, that's kind of interesting, you know, what's out there. And what was fascinating about the whole story is if you talk about wild terrestrial animals, okay, mammals, like the wolves, the lions, the elephants, the deer, okay, the wild mammals out there, 20 megatons of biomass of these wild mammals, okay, led, in fact, by the #1 wild mammal out there in terms of biomass. I don't know if you have these in the Netherlands. If you don't, we'll send you some of ours. The #1 mammal in terms of wild biomass is the white-tailed deer.
All right, yeah.
Do you have white-tailed deer in the Netherlands, or you have red deer? What do you got?
Roe deer. Yeah.
Roe deer. Okay.
Yeah.
Well, I'm sure they're on the list. Okay, of these things.
And
the deer, the even-foot mammals, that'd be Artiodactyla, and that's, you know, the deer and the roe deer and the whitetails account for 49% of the wild biomass, 20 megatons. Now, if you look at wild marine mammals, okay, so there's your seals and your whales, and they have 40 megatons of biomass, which is, so there's more wild marine mammals than in terms of biomass. And the whales are big. The whales are big than terrestrial, which I thought, well, I guess it makes sense. Remember when we learned in school, there's, I don't know, 3/4 of the earth is ocean, and
That's
I guess
right.
there's
Yeah.
a lot of stuff swimming out there, mammals swimming out there, right?
Yeah.
But the thing that two things that stunned me. So we're talking 20 megatons for wild terrestrials, 40 megatons for wild marine. Humans. Okay, so remember, wild animals, 20, wild marines, 40, almost 400 megatons of human beings. Okay, that's 10 times the wild 10 times wild marine mammals, 20 times wild terrestrial mammals. Okay, and you know, you knew that, you knew human population was huge, but then again, there's a lot of people, right?
There's a lot of people, huh? We've expanding over the past centuries a lot, obviously.
Very,
I guess
yeah, right. So far, but then the double thing. Okay, so humans 390 megatons. According to this analysis, cattle 416 megatons of biomass. Cattle alone. Okay, that doesn't include cattle, by far much greater than all the other domestic species, domesticated species. But so in combination, almost 800 between people and cattle, almost 800 megatons of biomass, far exceeding anything found in the wild, you know. And I thought to myself, It's fascinating, right? First of all, it demonstrates this link between human population growth and the growth of ruminants, which I think is pretty well documented, right? People, they like their cattle, right? Meat and milk, right? No question about it, you know. And
sure,
so
making use of the fiber that we humans can't use, basically. That's the
fascinating.
yeah.
Fascinating. And that goes on to your paper, okay? And your paper, which you also published in PNAS.
Yeah.
And you talked about the title of your paper, Full Adoption of the Most Effective Strategies to Mitigate Methane Emissions by Ruminants Can Help Meet the 1.5 degrees C target by 2030, but not 2050.
Yeah.
Okay. So can you explain why can we meet this by 2030? Oh, first of all, explain now we're moving beyond 3.0 because you talk about lots of different strategies.
Yeah, we evaluated in total almost 100 different strategies and did a large, if you like, meta-analysis on that. And the first surprising thing was basically that the majority of those strategies simply were not significant, or only had a very small reduction. So we see a lot. I also asked a lot by journalists, for example, that some company or someone comes with this, you know, silver bullet, and this is going to reduce methane, and then apparently it's only tested, for example, in vitro and not in animals itself. So there's a lot of different strategies out there which are proposed that are not effective, and that's one of the take-home messages of that paper of a very large group of researchers involved. But there are also, luckily, also a couple of very effective strategies. 3.0P is one of them, but you can also think, for example, on a better quality roughage does help to reduce methane. Not so much in the absolute amount of methane per animal, but because the animal is more productive, if you spread it out over higher amounts of product, the intensity, methane intensity, will lower. So less methane per unit of growth or per unit of milk, for example. Or there are other strategies like nitrate is a strategy that was very promising here, or forages that contains tannins. That's also a very interesting one. So that's also one that can possibly be utilized also in the countries that have a lower income, have less possibilities, so to say, to use more expensive feed additives. So also very applicable to them. So in the end, we ended up with only 8 effective strategies out of the almost 100 that fulfilled our criteria of a significant amount of methane reduction while not reducing the production of the animal. Right.
So you don't want to, because that has its own downside, reduce production and you go in the wrong direction. You didn't, but in this article, I just noticed, and I want to make sure I follow up on some things, but in this article, and don't let me forget to follow up on 2030 versus 2050, because we haven't answered that question, but answer a question for me. Okay, so we've talked about methane, we've talked about CO2, and we talked about nitrous oxide. Okay, I continue to be confused about which one is the real bad guy. Okay, they say methane is bad, but it turns over fast. CO2 is bad, it stays in the atmosphere longer. Nitrous oxide, I have no clue. Which one's the bad guy? All bad?
They're definitely all bad, obviously, but our fossil fuel addiction is, in my view, the most serious one, because indeed carbon dioxide stays in the atmosphere for such a long time. Methane as a molecule obviously is much more powerful as a greenhouse gas. But like you say, it has it's got a half-time of only 12 years. And that means if we can reduce methane to a certain level, we will manage to, in the end, not to have the methane concentration in the atmosphere increase, because then the breakdown of methane can keep the same pace as the levels that we emit. So methane needs to come down. If you can really decrease methane, the methane levels in the atmosphere will go down. And that's what people call, it's wrong, but what they call cooling. of the Earth. It's not really cooling.
Okay.
There's still this greenhouse gas there, but compared with a situation that methane concentrations go up, yeah, it's cooling. And I think that's a very important element that we should strive for, to reduce methane, because basically it's also required for the short term being a couple of decades, also to kind of, if you like, buy us time to also find good solutions to completely get rid of fossil fuel, because that's the carbon dioxide that stays in the air for hundreds of years.
Yeah, you mentioned fossil fuels, and I remember I was reading or speaking with people from Denmark, I think it was, and they were mentioning their success with offshore windmills in Denmark, and highly successful in generating energy, at least the way the Danes talk. Now, in the Netherlands, are you also experimenting with offshore windmills for?
Yeah, a lot. So a lot of offshore windmills in the North Sea. Yeah, that's delivering the energy. But obviously, well, most of the times you have wind on the North Sea, so it's a relatively steady source. But you can't bank on just one source of energy. So also, like, solar panels are a very important source of energy. We don't have like water power, and nuclear energy is basically a no-go in the Netherlands. So but like obviously the global situation, war, Ukraine, etc., has really also made it clear to the EU that we need to be probably not so reliant on other countries for such first necessities as energy.
Yeah, it's not simple. I mean, I think in America, we are, as you know, we like our fossil fuels here. Having said that, I think there's growing understanding that alternative sources of renewable energy have a place in America, you know, and but we're not there yet. And I always say, I have this saying that people won't, in America, people won't get serious about climate change until their flowers don't come up in the springtime, you know, and when it hits home that hard, right?
Yeah.
They're going to say, oh, we need to think harder. And I think it's starting to be there, because I think there's this notion in America that we have real extremes in climate that we haven't seen before. You know, in the state of Missouri, we had we all know about the California wildfires, but it was so dry in Missouri last summer. We had a wildfire near Columbia, Missouri, that wiped out a small town, 20 miles from here. And it was a situation where it was so dry. Someone was harvesting. They were doing nothing wrong. They were harvesting. A spark started the wildfire, and there was nothing to stop it. And now in Columbia, Missouri, we talk about wildfires. You know, it's unheard of. And it sounds like you've been dry in the Netherlands as well.
Yeah. And so we dry, and like if you go a bit more south, like in Spain, they already have experienced also large fires already in like March, April. Very unusual for that time of year. Very dry, and they're obviously very worried about high temperatures and how can they then still grow their crops in like in Spain in the dry, hot areas, etc.
It's so why not 2050? What happens in 2050 that you can't fix 2050?
Yeah, what happens in 2050 is that we expect the world population to still grow. We talked already about huge amounts of biomass, but that's going to probably go even higher than that. And that increase in population, together with possibly an increase in like wealth of people in Africa, Asia, that they have more buying power, who also would like to consume more animal products. That increase in animal product consumption is probably greater than what we can achieve with methane or strategies to reduce methane. So if you just would look, we also did it just for Europe. And for Europe, we can reach that target in 2050 with two of the best strategies. If we implicate that, then we'll be there. But in other global, other areas, this increase in consumption of animal products will be greater than what you can achieve by methane reduction in 2050. So that's also, you know, an alarm bell, if you like, that we need to do more and think about perhaps also on, is it really sustainable to have these levels of animal product consumption by people, but also look at more ways to reduce methane even further.
Yeah, I think one thing that's at least good news, particularly for dairy, is both at the industry level, the academic level, the farm level, we have really smart people that work at all levels of the dairy industry, you know, and I feel like if you put that challenge out there and we all agree this is what we want for our industry, I just sort of feel like it can happen. You know, I just feel like there's a lot of smart people and that are talented and care. And so I think it's, you know, we've never been one as an industry to shy away from challenges.
Yeah.
And this is another challenge, and it's a real challenge. And so we're gonna wrap up now. We've been talking for about an hour, and it's late at night there. I know it's I don't know what is it, 8 o'clock or something, and some crazy time, and I'm here around noon in the United States. But I'm just gonna skip. We always finish off with a few questions, and so I'm going to ask you some questions. Any favorite people, living or dead, science or non-science, that inspired you in your career, that really sort of moved you along?
Yeah, one of them is my professor when I started as a PhD student. That's Siep Dijkstra. He passed away last year, but he really inspired me to dive into the science behind things, and he also inspired me very much to look further than just Wageningen. At that time I was just, you know, in Wageningen, doing my studies in Wageningen, and he said, yeah, you have to go to abroad and spend some time over there. And that was when I spent my first 6 months as a PhD student at an institute in Hurley in the United Kingdom. It was a great experience, a great team over there, and I'm very thankful also for Siep for stimulating me to go abroad, right, and experience what research is there in other countries. Also, that inspired me also to take a postdoc position at another place in the United Kingdom, which was great. And the other person, that's my mentor basically from my period in the United Kingdom, that's Professor Jim France. He's now retired from University of Guelph.
Right.
But he also taught me basically how to combine numbers, mathematics with biology. And in the end, that's now basically my favorite, basically. I'm someone who likes mathematics indeed, that's true, but not just for the mathematics as such. It's all about how can I link that to biology. And in my view, you know, there's sometimes a bit too many people that just stick to the mathematics, are very good in it, but can't translate it to the biology. Or the other way around, you're very good in biology and doing animal experiments, for example, but the numbers don't have a great meaning to you. And what I like, and I really think it brings us further, is to combine those two and to learn from each other and to combine numbers with biology, which is also what I teach in my class that I give now. It's called Newton Dynamics, and that also the students work with models basically, which they link to actual issues in animal nutrition.
Right. So it sounds like another one of my questions, if you were not a scientist, what would you be doing? You'd probably be a mathematician or something else.
Oh, First of all, I'm very lucky that I had this opportunity to go into science and
Yeah.
do what I really like to do. Obviously, not every day is always as fun if you go to the red tape or whatever there is to distract you from the real work.
Yeah.
What I would also like to do, Matt, maybe surprised, but I would always have loved to start up my own microbrewery.
Is
So
that right?
brew my own beer. I mean, you've got some great IPAs. I love IPAs. So you got some great IPAs back in America, right?
Yes,
And
we do. Yeah.
yeah, making your own beer would be something that would also. I could have a nice life on that one as well.
That's
So yeah.
interesting. Sort of, sort of as a, you have a little bit of rumen microbiology in your
Yeah,
mindset. You just kind of
yeah,
transfer it over to the beer, and I
yeah.
mean, not the different bugs, obviously, but yeah, that's interesting.
Well,
It's fascinating, right? You're
fermentation
fascinated
process.
by how I guess it's microorganisms can benefit man.
Yeah,
Essentially.
yeah, yeah,
Yeah.
yeah. Obviously, microbiology is definitely one of my favorites for the
Yeah.
rumen, the beer, but there's so many areas where microbiology plays such an important role. Yeah.
I don't know if I could top that one. Finally, if you had, we get a lot of grad students, and we hope to get people that listen to the podcast that maybe they hadn't thought about science, or maybe maybe they're in it, but they haven't any advice for those types of people that, maybe an undergraduate who's kind of listening, or maybe a grad student who's trying to figure out where to go in terms of their research questions. Any advice that you got, or if you along the way, or that might help that type of person to think about things?
Well, it's you need some determination. Obviously, first of all, it's you need to enjoy trying to find out how things work. Hey, yeah, you need to
Yeah.
be curious, obviously. And I think the best advice I got probably is try to be or to have a controversial attitude, to kind of play devil's advocate in
Yeah.
what you try to achieve in science, because you
Right.
can probably learn a lot by looking at it, not in the conventional ways or
Mm,
follow your own line of thinking, but try to destroy your own line of thinking, if you like,
right. Yeah.
right? Play the devil's advocate. And what is then also very important is don't dismiss old literature. Just dive into literature from, say, the 60s or 70s.
Yeah.
Be amazed about how diligent and deep diving research at that time
Right.
could be. They didn't have all the techniques, sure, that we have
Yeah.
nowadays, all those molecular techniques or whatever,
Yeah.
but the thorough way they look about a topic and dive into it and work with the hypothesis, I
Mm,
think you can learn a lot from that, to look back basically decades ago and
right.
see what people did at that time and how they went about in doing science.
Right. Yeah. I think just those pieces of advice were just so spot on. I always tell my students that it's so important to enjoy what you do, and science is way too hard to do it if you don't enjoy what you do.
That's
You
for sure.
have to enjoy it, and I tell you, so those were tremendous comments, and I'm hopeful that those listening will take those on board, because could not agree more. So Jan, I just wanted to I've taken up a lot of your time today, and I just want to say thank you. Okay, your enthusiasm and your curiosity just comes through so strongly, and your optimism about dairying and where it's going comes through so strongly. And I really appreciate that. So I'm going to close the podcast and say a few words. And so this has been Dairy Digressions, and we've been talking to Jan Dijkstra from Wageningen University. And I would encourage you, for those listening, that if you enjoy the podcast or would like to leave any feedback, please do so at adsa@adsa.org. And also, please make sure to like, subscribe, and rate us on whatever platform you're listening to. So with that, Jan, thank you very much. Appreciate it.
Thanks very much for having me, Matt. It was a pleasure.
Thank you.